Now in this lesson we're looking at equations that have pronumerals on both sides. Now if there is a mixture of letter terms and numbers on both sides of the equation, what we're going to do is consider having all the letters on the left and then all the numbers on the right. Let's look at some examples. We're asked to solve the following. Firstly, 9x minus 7 equals 3x plus 11. Well, there's our letter terms. Okay, there's a 9x on the left and a 3x on the right there. And we can see we have numbers both on the left and right hand side as well. So we're going to try to get all the letters on the left. So let's write L for letters, numbers on the right, so N for numbers. We're writing that to remind us of what we're trying to do. So we have our letter term there, 9x. We're going to leave that there. That's fine. The negative 7 though, the minus 7, is our number term. We want to move that to the right. So when we move that, the minus 7 becomes positive 7. Okay, change side, change the sign. So we can see that we have our numbers there on the right, the 11 plus the 7. However, we need to get rid of that 3x, the letter term. Bring that to the left-hand side. So the positive 3x becomes minus 3x when we change the side. So let's see what we have at this stage. We have 9x minus 3x, that is 6x. Put our equals underneath each other. On the right-hand side, 11 plus 7 is 18. So all the hard work's done, now it's quite easy. There's our x. We want to try to get that by itself. At the moment, it's multiplying by 6, so we're going to divide by 6. Make sure we do it to both sides. On the left-hand side, those 6's will cancel, so we then have the x by itself. So x equals, and 18 divided by 6 is 3. So our answer there, x equals 3. Our second example, 15 minus 2b equals 8b plus 5. Again, letters on the left, numbers on the right. So there's our letter term on the left, negative 2b. Let's leave that there, but we need to move the 15 over. And the positive 15, when it comes over, becomes minus 15. So on the right-hand side, there are our number terms. Our letter term 8b we need to shift. So the positive 8b, when it comes over, becomes negative 8b. So on the left-hand side, we have minus 2b minus 8b, which is minus 10b. On the right-hand side, 5 minus 15 minus 10. So there's our b. We need to get it by itself. At the moment, it's being multiplied by the minus 10, so we need to divide by minus 10. Make sure we do it to both sides. On the left-hand side, those minus 10s cancel each other out. So then we have the b by itself, so we write b equals, and minus 10 divided by minus 10 is simply 1. Excellent. Some further examples now. Example 3, 3a plus 2 equals 4a plus 9. Letters and numbers. Now there's our letter term. Let's leave that there. Let's move the plus 2 over. When it comes over, it becomes minus 2. There are number terms now, the 9 minus 2. The 4a, though, needs to get shifted to the left. So when we move the positive 4a over, it becomes minus 4a. So we have, on the left, 3a minus 4a. Well, that is negative a. Put our equals underneath each other. The 9 minus 2 is 7. Now, if we have minus a equals 7, okay, we don't want minus a, we just simply want a. What we can think about is really as being negative 1a equals to 7. So to get the a by itself, we need to get rid of the negative 1. It's multiplying, so we need to divide by negative 1 both sides. Those negative 1s on the left will cancel, so we get a equals, and 7 divided by negative 1 is minus 7. So the minus a, let's have a look, becomes positive a, and the 7 becomes minus 7. That's a quick way of doing it without having to do the stuff on the right. So if you have the negative a equals 7, we can just basically swap the signs. A equals minus 7. Now a little note here. Let's say if we had minus x equals minus 8. Okay, quick way we could do that. Change the minus x to positive x, change the minus 8 to positive 8. So our answer there would be x equals 8. Excellent. Well, that concludes our lesson. Good luck with your questions.